What's up, guys? Let's take a look at another CodeWars exercise. This one's a level 7. It's not too hard, but we want to get in the habit of recognizing patterns. The first time you do a level 7 like this, it might be tough. You might have to use some creativity and open a tab and Google how to do things. But after you've done 10 of them, well, the 11th is pretty easy. You take a look and you go, oh yeah, I know where it's going to start. I have an idea where it's going to end. I just have to figure out the little details in the middle. So what are the details for this one? It's called Alphabet War. We have two groups of hostile letters. The left team is W, P, B, and S, and they each have a rank. W is worth the most, and so on. And then the right side is mirror images of those flipped horizontally or vertically, so W becomes M, P becomes Q, etc. And very similar ranks. The other letters are neutral, they don't matter. And so as an example, if we get a Z, well, that's 1 for the right team, none for the left, right wins. This one, I'm not going to go through it, but you can imagine maybe 1, 2, and 2 on one side, and maybe 3 and 2 on the other, balancing out. So our output, no matter what, is either left, right, or neither. So let's begin and see how it might go. The first thing I want to point out is this. Whenever you see a chart, left and right columns, look something up, find the value, look something up, find the value. That's a very good clue. You might want a dictionary. We did this recently with the smiley face one where they had ranks used for sorting. And so the smiley face is worth 4, the next one's worth 3, whatever. This is not used for sorting, but it's still extremely helpful to be able to look something up and get a number. Because a number can do math, it can do orders, it can do all kinds of things. And letters or smiley faces or anything else, not so easy. So let's copy this and start a dictionary, and then we can use it for convenience later. That was the left team, so maybe I'll call it left. And then I got to do some punctuation. We got quotes, we got colons, and we got commas. I'm going to put it on one line because it's so nice and short, but that does lose the 2-column chart look, so feel free to keep it spaced if you like. The next part is the right, and it's so similar, so I'm just going to copy, and all we have to do is change right, and then the letters are mirror image, so W flips to M, P flips to Q, and D and Z. Now the loop is just going to go through left to right, look at each one, see how it scores. At the end, we'll see how many lefts and how many rights, and go from there. So I'm going to say 4-letter in fight is what they call it. You could just branch off into 2 paths. If letter in left, we do one thing. If it's in the right, we do the other thing. So we'll need a score for each one, maybe. So the score gets, you can't just say 1 because they have different ranks. So M is 4 and D is 2. We have to look it up, so that's what this left letter is. We look them up one at a time. And then for the right side, we do the same thing. We can say if it's in the right, well then right score is the right lookup. Now the problem with that is we have to create left score and right score. And honestly, I think this would work, but it's getting pretty tedious, right? We've got 2 dictionaries, 2 values, 2 if branches, and I don't even want to type the second half where it's like, okay, left wins, right wins, whatever. Let me print this to see if we got anywhere near, and then I'm going to try to find ways to condense it and make it a little more clean. So I'm going to print left score and right score, and then I'm going to test that. So we got 0-1, it should be right winning, yes. 10-10, it should be a tie, yes. 4-3, it should be left, yes. So we're getting the right answer even though we're not properly formatting a string. We're on the right track. However, like I said, I really don't like this. I want to be more straightforward. Whenever you are doing something simple, and adding up scores for two sides is pretty simple, you don't want to say, well, okay, if it's this thing, you look in this dictionary and add to this. If it's this other thing, you look in this dictionary and add to this. I'd rather be more straight down the middle, one path, one thing. So let me give you one tip, and this is not just for here, but in a lot of different problems. You've got a balance between two sides. You've got something pushing one way, something pushing the other way, and a possible zero in the middle. And whenever you do that, there's a way. There's already a built-in way. Our numbers are perfectly happy to do two sides, and that's negative and positive, right? We have, I think we've seen this once when I did the parentheses. I had like the left parentheses count as one side and the right parentheses count as the other side, and one of the things was it had to be zero at the end. And this works here. We even use the words left and right for those all the time. If you're looking at a number line, if you're looking at a graph, well, left is the negative direction and right is the positive. So let's combine these and make it one thing with lefts being negative, and obviously we're not going to call it left anymore. We could call it score or something like that. And then we don't have two values anymore. We could call it, let's say balance. I think that's what I called it in the parentheses problem. And then we don't have two branches anymore. We just need one. So, balance plus equals score of letter. And so now we're not printing two things, we're just printing one. And so if the balance is negative, that's on the left. If it's right, or if it's positive, it's on the right. Let's see if that works. Okay. Oh, I accidentally left the name. So that's going to be right is positive, none is zero, left is negative. So that is the right number. We just have to do the thing with the strings. So let's do that, okay? We can say if balance is less than zero, we return this thing. And then we can copy if it's greater than zero, it must be the right. And then if it's got past both of those and neither one has done anything, then it must be the other side. Oh, look at that. They use double quotes here and single quotes here. It feels weird. But now if I test this, hey, we got it. Great. We're done, right? Well, I do want to change one more thing, which is another pattern. Okay? So like the idea of seeing the chart set up, that's a pattern. If you see that, you might want to have a dictionary. Okay? Going through a string, well, you might do a for loop. That's a nice pattern. This I'm not thrilled with. We can find a way to maybe have a single return, but that's fine. However, here's a pattern that you're going to see a lot, and that we have seen a lot. If you have a number and it starts with 0 and we add up as we go, well, we've done a couple problems that use that, and it has a name. It's called sum, okay? Sum is a function. It's an English word. I guess it's a word in a lot of languages because it probably comes from Latin. And we can just say that instead of doing all the dirty work ourselves, like starting at 0, adding them up, doing something with the result. We can just say, give me the sum of these. We did that once with even numbers, I think, and it's really nice. So let's just say sum of this thing for this thing. And I wish that would work perfectly, but it's actually a tiny bit off, okay? It's going to pass the basic tests, but then when we go to attempt, it's going to say, hang on, that only works if the letter is in there. If we try to look up Z, well, that's fine. If we try to look up F, we get an error, right? So that's the classic key error when you look up something in a dictionary. And there are a couple ways we could solve that. We could do try except. We could do the if thing. Like, remember we had an if. We could do that again, but I don't really want a super long line. So instead, I'm going to use another thing we've talked about recently, which is the dictionaries get method. Okay, the get method is a way to look up with the default, and you have the default, so if we don't find it, we'll just use 0. 0 has no effect on the balance because it doesn't tip toward left or right. So if I try that, we're going to pass all the tests. Great. I really like the idea of using the sum because A, that's what it is. It could have been the kind of thing that would show up in the title. B, it's less typing. C, it doesn't have branches. You don't have to think about, well, if it's this, we go this way. If it's this, we go this way. And then you kind of like backtrack in your mind back to the original. No, you just say, give me the sum of the scores. Great, that's a thing. We all know how to do that. We all know how to express that. And we all know what that means. The bottom half, I wish there was a cool way to phrase this. There are a couple tricks we could do, but it would only bring down the returns to 2. You know, it's pretty hard to bring it down to 1 unless we have a big old massive block in parentheses with like return this, if this, else this, if this, which is not really any better, right? So I'm going to leave this here, but I want to take a minute and look at the solutions from other people, because you have to remember they encountered the same problems we did. They said, okay, do I want 2 scores and 2 numbers and 2 branches, or can I combine it? And do I want to look it up, but what happens if it's not in there? And do I want to return, but how can I try to do less than 3 returns? So they're going to come up with solutions that might be the same or they might be totally different, but you have to remember their problems were the same, even if their solutions aren't. So let's see what the first guy did. Very similar to ours. We got a dictionary. For some reason, he made the rights negative instead of the lefts. That feels off to me, but it doesn't matter as long as you get your greater than and less than. And he did this with the dictionary because I know it's annoying to say return 3 times, right? The dictionary is a little bit annoying to me because you're looking up true. It just feels weird to look up true instead of looking up like a variable, like something from our code. It feels like these should be outside and this should be inside, but it works fine. And then this person, if you remember on the happy face one, there were some people, including us, who ranked them in a dictionary, and there were some other people who ranked them in a list. You made a list and then you used the index method to find out what order it was. And I said that would have been good if we were going to change it a lot and we didn't want to have to rearrange all the numbers. But I ended up liking the dictionary. For this one, I think it looks pretty weird. The string method find is the same as the list method index, I think. Or maybe they have a difference in what they do if they don't find it. But it does the job. It works well. Good for him. This one is kind of like our first draft. It has a left score and a right score, which means 2 dictionaries, 2 branches, 2 numbers. Not the greatest. Actually, it's not really 2 branches. It's just using the get method to plant a bunch of zeros. And then we see a bunch that are pretty similar. I like this one because he does the dictionary. 1 dictionary, he does left negative, which I like, and he labels them just to make sure. So that's very readable. I hope that person feels good about it. I gave him the clever upvote, sure. This one, you know what? You can always do ifs. You can just branch every single possibility. I find it not just hard to read, but like impossible to read. Like when I look at that, my eyes just unfocus and it turns into a blur. But it works, apparently. Now, if we scroll, we'll see pretty much the same stuff. Most people did a dictionary. A couple ones are trying to be cute and use the find. Actually, this one is cute because he makes the dictionary instead of typing it by hand. And this is the right setup, like the one I like, where lefts are negative and rights are positive, because enumerate second parameter allows you to start. So this is like start counting here, and then 0 is the space, and then these other guys. It's great. I love it. Now, that's pretty much it. I'm sure we would find some wild outlier if we scrolled long enough, but that's pretty nice. I like this one because it's not perfect, like because at the end you always have to say 2 or 3 returns and it's always just a little bit annoying. Sometimes real life problems are like that, and you can't express them in one beautiful line, and you have to use your, you have to like show your personal style and how you handle these little annoying exceptions. So, oh, there's another one with the enumerate -4 thing. That's nice. Maybe I'll do that in the future. If you ever see a problem like this in the future, what might you take away? 1, dictionary, use them. 2, if you have 2 counts, you might use negative and positive instead of 2 separate things with 2 separate scores and 2 separate things to look at. If you have adding, consider doing a sum instead of a loop. If you have a bunch of returns, it really depends. It really depends. Sometimes you can say one strong, straightforward return, and other times you have to if. And sometimes you have to do one right at the beginning, or you might say, if the input is bad, then we return before we even start any of our business. So think about those in the future, and remember that none of these are standalone. Whenever you open a problem, it's always connected to what you've done before. You can think, oh yeah, you know what, yesterday I did one to the dictionary, I'm going to use it again. Even if it's not perfect, it'll give you a head start, and it'll be better than staring at a blank page. There you go.